All right, here we go. Here is the quotient property of square roots. It's the same as the product property of square roots, except now there is also a denominator. So the trick is that there cannot be a radical in the denominator. But luckily in this section, most of your denominators are going to be perfect squares or contain perfect squares. So let's look at example 3. Social distancing rule applies to the quotient property as well. If the entire fraction is inside the radical, they each get their own bed or home. So we're going to separate this into radical 17 over radical 25. Now we can simplify this. Because radical 17 is a prime number, we don't have to do any prime factorization or perfect square, greatest common factor, or anything like that, because radical 17 is going to stay radical 17. But if it was factorable, you would use prime factorization to factor it, and I'll show you another example of that. Now the denominator, radical 25, that is a perfect square. So the square root of 25 is 5. So your final answer in simplest form is radical 7 over 5. Let's go down to these checkpoints. Now let's see. The numerator, number 5, is in simplest form. It's prime. You can't do anything with it. Number 6, 21, that can be simplified. The numerator can be simplified. Number 7, the numerator can be simplified. And number 8, the numerator can be simplified. So I am going to do an example. I'll use number 8 as my example. And then you are going to do the rest of the checkpoints on your own. So for number 8, I am going to rewrite this fraction using the quotient property. So I'm going to rewrite them in their own separate radicals. 32y squared over the square root of 81. Now, since this one has a variable with an exponent attached to it, I'm going to separate it even further to give me radical 32 times y squared. Now we can do some prime factorization, and if I move this down a bit, we can do some lazy prime factorization. Over radical 81. So my lazy prime factorization is just going to go straight up. We're going to prime factor up instead of down. So 2 factors of 32 would be 8 and 4. You can also use this for greatest common factor factoring. Then we're going to go 2 and 4, 2 and 2, and this guy here is 2 and 2. So 1, 2, 3, 4, 5 2's. 5 2's. And y squared is y times y. So we are going to rewrite this again. Put that over a bit. Rewrite this again. 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. Whoops. Times y. Still not long enough. All right. All over radical 81. Okay. Let's find our pairs. We have a pair of 2's. We have another pair of 2's. And we have a pair of y's. Cross one out. Bring it to the outside of the radical. And our other set of 2's. Cross one out. Bring it outside the radical. And our y's, cross one out, bring it to the outside of the radical. So we have 3 factors coming out of the radical and 1 lonely 2 staying inside the radical. So we are left with 2 times another 2 times y times radical 2 all over radical 81. And now we can finally simplify. 2 times 2 is 4. 4 times y is 4y. 4y radical 2 over the square root of 81, which is 9. So that is our final answer, 4y radical 2 over 9. Now, a simpler way to do this would be to use the perfect square factoring. Perfect square factoring would get this done a little bit more quickly. Again, you do not have to use it. I just want to show it to you. So if we have radical 32y squared over radical 81, right away you know square root of 81 is 9. And you also know that 32 can be broken up into 2 times 16 times y squared. So you're going to give everyone up top their own home. Radical 2, radical 16, radical y squared, all over 9. Okay. Now, radical 2 stays radical 2. That's a prime number, can't be factored any further. Radical 16, perfect square, that equals 4. And radical y squared, another perfect square, that equals y. So we need to use the commutative property to rewrite this in an appropriate order. So we are going to bring down the 4, y, radical 2, and all of this is over 9. Same answer, 2 different methods. And you can also use a combination of these 2 methods. Figure out what works for you. So that was your example. Now you are going to do the other 3 checkpoint problems. Pause the video and come back when you are ready. Alright, here are your final answers. I definitely did the most challenging one with you, and the rest of them were very few steps. So number 5, you separate the fraction under the radical and give everyone their own home. Radical 5 over radical 9. Radical 5 is a prime number, so you can't factor this any further, so it stays radical 5. The square root of 9 is 3 because 9 is a perfect square, so your final answer is radical 5 over 3. Number 6, we separated the 2 parts of the fraction into radical 21 over radical 64. Radical 21 can be broken down into 3 times 7, but both of those are prime numbers and can't be broken down any further, and there are no pairs. So when you multiply 3 times 7, you still get radical 21. So radical 21 stays, and the square root of 64 is 8. Radical 21 over 8 is your final answer. Number 7, radical 16z over radical 49. I separated 16 and z and gave them their own radicals. So you can see that radical 16 is a perfect square, which would give you 4, but radical z is not a perfect square, so z has to stay in jail. And then the square root of 49 is 7, so your denominator is 7. 4 radical z over 7. And then we already completed number 8, which was 4y radical 2 over 9. Let's scroll down to example 4, using radical expressions. So we are given the expression radical h over 16, which is supposed to give you the time in seconds it takes an object to fall h feet. So we need to write the expression in simplest form and then find the length of time it's going to take for an object to fall 120 feet. So first let's simplify the expression we are given. we're given radical h over 16. Well, we know we can't have a radical in the denominator, so we need to separate this and give each part of this fraction its own home. Radical h over radical 16. Can h be simplified any further? No, there is no exponent, so this is prime. So radical h stays radical h over the square root of 16, which is 4. So in simplest form, the expression that we were given becomes radical h over 4. So now we are going to use this information and substitute 120 for h, because we want to see how long it takes an object to fall 120 feet. So we would plug in 120 for h, because 120 is the starting height and h is the variable representing height. So the expression we're plugging into is radical h over 4. So radical h would become radical 120, radical 120 over 4. Now I am going to pull this out over here because we are going to need to simplify radical 120. This does ask you to approximate using a calculator because you would not give your answer in radical form if you were doing a real-life problem. That would be silly if you told someone an answer in radical form. And we'll see that after we simplify over here. I just want to practice simplifying. So radical 120 over 4. We're going to do some prime factorization in an upwards motion. What are two factors of 120? Well, you could use 12 and 10. That becomes 5 and 2. This becomes 3 and 4. And then 2 and 2. All my prime numbers are ready. So we have radical 2 times 2 times 2 times 3 times 5. My pair of 2's. Cross one out. The other one goes out of the radical. So we are left with we are left with 2 on the outside, 2 times 3 times 5 on the inside, all over 4, which equals 2 times radical 30 over 4. Now this is something else I wanted you to see, which is why I didn't want you to just plug the whole thing into the calculator and find the approximation in decimal form. Because 2 and radical 30 are being multiplied, because they are factors, that means anything in the denominator can simplify with a coefficient if possible. So in this case, we have 2 and 4. This could be written like this: 2 over 4 times radical 30 over 1. 2 and 4 can be simplified. 2 over 4 simplifies to 1 over 2 times radical 30 over 1, which would give you radical 30 over 2 as your final answer. Now, the last thing we're going to do is this checkpoint problem. So you are going to use the same expression we were given in the beginning, but you need to figure out how long it's going to take an object to fall 150 feet instead of 120 feet. I would like you to simplify first before plugging it into the calculator. Pause and come back when you're finished. Did you figure it out? The only factors of 155, other than 1 and 155, would be 5 and 31. 5 and 31 are both prime numbers, so they can't be simplified any further than that. So you end up with radical 155 over 4 again. So you're just going to put that into the calculator, and it will take approximately 3.1 seconds for an object to fall 150 feet.